Hey, Charlie, over to you.
You're
Oh, go ahead.
all set?
Yeah, all set. You're all set. Please go ahead.
Okay, all right. Share my screen, portion of my screen. Yes.
Yeah, we're able to see your screen.
All right, let me go there. Everything okay? All right, guys.
All set.
All right, thank you everyone for dialing in on this webinar today. Hi, my name is Charlie Berger. I'm the Senior Director of Product Management for Oracle Machine Learning. I'm based out of just outside of Boston, Massachusetts. So I'm here to try and tell you a little bit about something I think is pretty cool. We have free now inside of every database, free as of December 5th, 2019. Oracle, Larry and all made the decision to make the certain features of the database free. So spatial and graph also did this, and Oracle Machine Learning, something that you may have also heard of it as Oracle Advanced Analytics, Oracle Data Mining, Oracle R Enterprise, all those kind of names that you might have heard over the years. We got our wits about us and cleaned up all the names. Now everything is called Oracle Machine Learning, but everything I'm going to talk about now is free. So I hope you can take advantage of this and have some fun. So this presentation's, it's a little bit, a little bit long. There's a lot here, and I can go into demos or answer questions. So please make this as interactive as we can with Zoom these days. The first part of it's going to be a little bit, probably a lot, about what the product is. And the second half, if you believe the first part about like what it is and what it does and how it's kind of not that hard to use, then the second half goes into a little bit more of a detailed journey or a path for a way to approach evolving your skill set. My assumption is that not all the people on the call right now on the Zoom are say data scientists, and that maybe some of you want to pick up and add those kind of skills to your other Oracle skills. And my observation is that that's a very doable, very logical, very achievable kind of thing. And I'll give you a little bit of a roadmap about how to go about doing that, other than going off to get a PhD in something or taking 1,000 courses. I think a lot of it's just sort of common sense and a natural sort of evolution. So with that, I'm going to try and dive into some of this stuff and see how this goes. So if you have any questions, you need to reach out to me for anything. You can just reach me at charlie.berger@oracle.com. If you have extra free time, you can follow me on Charlie Datamine on Twitter as well. But back to here, the main punchline is this thing over here in the left-hand side where we say we move the algorithms, not the data. And this stems from an architectural decision we made way back in 1999, when I and a bunch of us, there was about 30 of us that got acquired, one of the rare acquisitions from the in the server technology database side of things. And they acquired a company called Thinking Machines, where I and a bunch of us worked. And we already had developed massively parallel processing, neural networks and clustering algorithms and those kind of things. And we had this shared vision with Oracle that as the volume of data got larger and larger and larger, that at some point you would reach this critical point where the data was sizable enough that it didn't make sense to move the data to some sort of mathematical platform. It made more sense to teach the math to the database. And so that's what we do. Like I said, there's about 30 PhD smart guys that sit within the database, and they write algorithms, and they write them as C code. So it's in the kernel of the database. These are SQL functions. They are not PL SQL. They are not R. They are not Python. They're not TensorFlow. They're not anything like a foreign object or a different thing. They are pure 100% Oracle database technology. We also integrate and expose those powerful 30-something algorithms to other languages and APIs like Python and R and notebooks and SQL developers, drag and drop GUI, that's something we call Oracle Data Miner. But at their core, they are SQL functions, and that's what changes everything. That's what makes it so natural for Oracle data professionals to learn about these things that are now free learn how to apply them to their own sort of use cases and learn how to build predictive applications and so on, and take it so much further than what people have been doing in the past with these two sort of disparate, data management math platforms. Now they're one combined hybrid converged database that does all of that. And that really sort of changes everything and opens up a lot of opportunities. And I'll try to explain some of that now. So I always like opening up with something with Larry, because people kind of wake up and go, oh, that's Larry Ellison, like the sixth richest man on the planet, and what's he up to now? This was at Oracle World. I sat up in front, where I always have for like 22 or 23 Oracle Worlds now, I think it's been. And he's talking about the Converged database, but he's also talking about my stuff. He's talking about Oracle machine learning, and he's talking about some new features that we have called AutoML that does, it's for simple integrated machine learning, whatever that means. It's just sort of more and more automation. We already do a lot of automation now, but there's even more, and it's called AutoML, and I'll talk about that a little bit later on. But what we've done is to fit into the mission statement of Oracle, we've added these machine learning algorithms that are we've been doing it for 20 years now, that are now part of this Converged database. And the Converged database then allows you to, extract more information from the data to actually make predictions. And I think, as they say here, help with the mission statement, which is to help people see data in new ways, discover insights, unlock endless possibilities. So that's what we do, being part of the Oracle database. It works so well, because if you're worried about security, it's all there. If you're worried about backup and disaster recovery, it's all supported by all the other features and functions that the database does so well. JSON documents, in memory, spatial, graph, aggregations. There's all these plethora of different features and functions that are available now in the database. Add to that all these machine learning algorithms, and you've got one pretty powerful platform. And as I've said, and hopefully we'll say, way too many times, it's all free. So you don't have to put any quarters in, you don't have to do anything special. You just get to go to the manuals and go down to the M's and look up machine learning, and off you go. So I'll be a little bit of your tour guide here, showing you some of these things. By the way, if you have any questions, just add them into the thing here. I guess it's probably early for questions. I don't see any questions popping up here just yet, but speak up if you do have any questions. One of the things that happens, I think, by this Converged database is that more and more you have this natural evolution that kind of goes from architect to data scientist to application developer. It's just this sort of moving up the food chain, if you will. Not that architects at the bottom or anything like that, but for architect, DBA, some of these things are like turning the lights on, switching everything, getting it going in a well architected, secure, stable, whatever kind of way. And more as Oracle certainly moves to the cloud with the autonomous database, a lot more of that is done for you, to the point where even I can log into a autonomous database, or I have it on premise on my laptop here, but I can be my own DBA, if you will, and let other users in and fire up notebooks, and off we go. So it really, I think, allows people to start to apply their deep skills and knowledge to things, beyond maybe what they've been allowed to do in the past, because they have more free time, or the features get easier to use, for whatever reason. So then when you do this, one of the things you might want to do is machine learning. And I assume that not everyone on the call is a machine learning expert. I imagine some people are, and some people maybe are not. So for those who are not, I want to kind of just give a real quick definition of a few concepts in the beginning here. So machine learning is just automatically sifting through large amounts of data to discover hidden patterns, new insights, and hopefully oftentimes to make predictions. And depending on what you're doing, the top three, I think this got to build properly. Whoops. The top three are what we call supervised learning. The bottom three are what we call unsupervised learning. Supervised learning means I have labeled data. I have data about who defaulted on a loan in the past and who did not, who voluntarily left the company, employee attrition, who did not, what your favorite color is, red, green, or blue. Are you married or single? Do you own a Tesla car or a gas-driven car? And it's not always a binary problem, but oftentimes they do get boiled down to something as simple as that. And so when we're trying to categorize something into A or B or A, B, C, D or whatever, like sentiment analysis or whatever, It's called supervised learning. That particular use case would be called classification. But we have related things, like if I'm trying to actually predict a numerical value, that's called regression. If I'm trying to identify the key factors that are driving, a prediction or outcome, that would be called attribute importance. If I'm trying to do other things, like just say I've got a bunch of data, I want to try and find the patterns and relationships that are in that data. Show me what patterns exist in this cloud of data points. Well, I've got a bunch of guys here, mostly red triangles or blue crosses or whatever, blue X's. That would be called clustering. We're trying to find natural subsegments of the data. If I'm trying to find these outliers over here, these rare events that could be fraud, that would be an anomaly detection algorithm, and we have something special called a one-class support vector machine. So on and so forth. There's different major categories of what we typically do, and people sometimes think that machine learning can be applied to anything. I mean, I kind of do, but I also don't, because it gets oversold sometimes. Now, this is something I found on the internet where they were talking about where machine learning was applicable, and I thought that makes pretty good sense. I rather than write out my own list, I'll just steal this. But I looked at it, and what I've done is I've underlined in red the ones where I've had some fingerprints on those kind of use cases, worked with some people, did it myself. You can kind of validate that, yeah, my product's been used in those places. It kind of makes sense. And notice I haven't underlined all of them. They're not that it doesn't make sense, but it just makes a little bit less sense to me that some of these things would be perfect use cases for machine learning. Maybe I don't understand the use cases, but that should give you a little feel for the kind of things that people typically do. Oracle's machine learning has a unique advantage that I wanted to kind of highlight in this slide here. Now, Fern Halper is a very smart woman who did a very good study and asked a very good question. She said, how long does it take to put a defined model into operational use? Now, a defined model is key, right? It means I've already been the data scientist. I've used Python or R or MATLAB or SPSS or SAS or something, and I've built a model, and I've got a pretty good predictive model for, I don't know, a recommendation engine, or predicting defaulting on loans, or who's gonna, what the value of your property is, something like that. So how long does it take to put that model into operational use, into some sort of enterprise application where I go to my Droid or I go to my dashboard or whatever, and there's a prediction there? And it was kind of eye-opening, but it also matched everything I'd seen and heard anecdotally with customers over the years. And it was mind-boggling to actually see it in print for me. 3 to 5 months, 6 to 9 months, 9 months or more. I think this adds up to something like 65% are 3 months to basically never, right? She didn't actually list out never, but not implemented would be one of the categories there. And very few are very, very quick and short. Now, I look at this and say, now this is my editorial comment, they must be using products like that, because if they were using my stuff, it'd be immediate. I'd just run a script, apply the script, and I'd be done. And in fact, I'm going to try and show you that over here, just kind of jump out of here for just a half second. I'm going to show you a real quick vignette kind of demo here with SQL Developer, but what we're doing over here is we're using SQL Developer's what's called Oracle Data Miner. It is an add-in to that, so you just kind of configure it, and you have all these little, where was it over here? You have these these sort of workflows here, but I'm not going to go straight to this workflow. I'll show this a little later on. Underneath this button where I'm going to go build some models here, I'm going to build a generalized linear model, support vector machine, and so on. Under the hood, what that's actually doing is this little bit of code over here, and I'm just going to run this right now with, this is a settings table. I keep on getting a little zoom floating thing around over here. This little settings table that just says, tell me what I want to do. I'll do it support vector machine, auto data preparation on. Now, this is the explicit way of kind of calling out what I want to do. I could do something where I would say create model 2. I can get that little guy to light up. I could create model 2 right there, and I could put those parameters down here in that, but I've got it sort of set the classic way of doing that. So I'm going to use these parameters here. Auto data preparation on means I'm going to do things like if I have missing values, I'm going to replace those missing values with the mean or the mean or the mode. I can do various different kind of settings there. I've already done that. Now I'm going to build the model. So when I build the model, I'm doing about 15,000 records, about 20 something variables, and I'm doing it on my laptop. So if you had a larger amount of data, you'd probably have a larger database and a larger server, to run that database, and you probably have very similar kind of results. So they just finished in like a second there, right? Once I've built that model, I can apply the model, and I'll just score all the records in the database and show me the top 5 most suspicious claims. So pretty cool, right? And if I want to just run this whole thing again over and over and over again, every day or every hour or every minute, I could be building a model, and then here I'm deploying the model. I could take this model, it's a first-class object in the database, and I can move that from a development database, maybe on-prem up to another one in the cloud, or from cloud on-prem, or from on-prem to on-prem. It's just an object in the database. It's no real difference from maybe moving a table or something, right? Or a script. It's just it's a model object that has all the logic of that predictive model that we've learned from running it on the data, but it's pretty straightforward. So if we go back to Fern's analysis here, you'd say, well, why would it take so long with those things? Oracle just does it architecturally. We've moved the algorithms to the database, and it makes it very straightforward. Now, there's this other study that was done, some sort of analysis, anecdotal thing, saying 87% of data science projects never make it into production. So there's a few corroborating pieces of data out there. And what they are talking about here is the fact that when I do build a model, typically in Python or R or SAS or whatever, the model has been built in a different language. And there's a lot of mechanics that are involved with these models. For example, just one that comes to mind is if you have a model that has both age and income in it, typically to make the model work, you have to normalize those 2 input variables. The age is like between 0 and 100. The income might be hundreds of thousands or more, billions of dollars, who knows. You want to typically scale those things down to 0 to 1, something like that, or -1 to 1, something like that. And why? So the coefficients don't dwarf each other and the math works better, is the simple way of saying that. And then if you've done all that with all that tedium and a lot of things worse than that, a lot of derived variables, what we'd call engineered statistics, then the data scientist comes over and says to the engineer or the DBA or the data professional and says, I'd like you to productionize this. And the Oracle data professional says, what the hell is this? What are you doing? What are all these variables? What are these transformations? And that's where everything kind of stops. It just does not translate very well. And what they do is they manually recode all that logic. That's why it takes weeks or months or longer to do it. Or sometimes they set up VMs. I was working with a customer the other day doing check fraud, and they had 900 variables using Python, but they would just run the whole thing in this outer loop in a Python VM. And that's fine, but they're running the same algorithms inside the database now using OML. Actually, the company's named Certergy. They do check fraud, and they just did a tech cast with us. And I forget what the previous times was, but hours or days to run the models before. Now they're just running them in, just like that inside the database. So that's the architectural difference between the two. Let's see if there's any Q&A or questions up here so far. I don't see anything yet coming in, so speak up if you do have anything. No open questions and no chat. So what I'm talking about is called Oracle Machine Learning. And like I said before, it is known by different names. It also has different APIs. It has Oracle Machine Learning for SQL. That's the core stuff that I've been talking about. On the autonomous database, we have these Zeppelin notebooks. They're called Oracle Machine Learning notebooks. When we integrate with R, we call it Oracle Machine Learning for R, Oracle Machine Learning for Python, Oracle AutoML. That's the new user interface. I'll show you a teaser of that and so on. But the key is, regardless of what language or user interface you want to use, we're trying to make machine learning simple, right? We speak different languages, different user interfaces. All this is just running at the core inside the database as these functions, and there's a lot of automation in those to make it sort of easier. The way that we've implemented this is per the following. What's the question here? So what should be the learning path for looking at? That's the second half. That's the second half. So Ashish, hang tight though. I've got a little bit more time to get to that, and I will. There's a blog. If you get antsy or want to go jump ahead, just Google Oracle Machine Learning blog, and you'll see something about a blog series. There's a bunch of links and things in there. I'm going to carve out some of that later on here. So the career path is, one, to know what it is, right? And then two, know how to best exploit it and how to properly apply it. And I'll get into that because that's where I see most people kind of, to be honest, sort of mess up. But what we have is this algorithm, which is called the naive Bayes algorithm. It just counts things. That's just a conditional probability counting kind of algorithm. we put that, if I can get this mouse to go, we move that inside the database. So when you run the database, it's going to do that counting for you. Okay, Sherry, thanks. You can Google it and jump ahead if you want, but I'll get to that in the presentation. That's the sort of the second half. So we move that algorithm. It's a, every time I take my mouse off here, it moves. So that is just counting, right? It counts the number of times that the person who bought a motorcycle was gender male versus gender female, was rented or owned, and was a dog lover or a cat lover. We're just counting, right? And if I count all those things, I get a prediction probability model. And you might ask, well, what do you do when you get a variable like age or income? It's a numerical value. Well, we just bin that into 10 or 20 bins, and we count, oh, you're in age bin 7 and income bin 3 and so on. And then we discretize that, if you will, and count it. Now we do things way more complicated than that when we put in, say, neural networks and support vector machines, and we integrate it with Python, and we integrate it with R and so on. But the key here is to grasp the idea that we taught the database how to do higher level math. The database, when we started this journey, did not do IEEE float. It did not support parallelism with a recursive infrastructure for doing like decision trees. And we work with, our PhD smart developer type guys, but also the rest of the other 5,000 guys in the database. And we'll ask them to do certain things for us. And hence we kind of just sit within this, greatness stands on the shoulders of those before them. And that's what we do. We leverage all the other strengths. So when we do text mining. We use Oracle text to tokenize all that unstructured data and bring that in as a vector of terms. So it really transforms the database into much more of what you might call an AI database. And I hesitate to say that because I did live through, the second AI winter in the 80s, I guess it was. So, I mean, I think it's a way oversold term, but everyone's talking about AI these days. And, that's pretty much what we're doing here, right? We're finding, we're not doing, it depends on what your definition of AI is, but certainly machine learning sits within that world. And if you have 500 variables in the database, you could use the other 499 to predict the 500th one, and you could do that for all 500 variables. So instead of holding 500 variables, you could have 1,500 data points, right? The actual, the predicted, and the probability. And in fact, the reasons why. So you could double or triple the amount of sort of information just by applying all these algorithms intelligently, and that's what we'll get into. And so now you almost have like a thinking database. It's very interesting. The algorithms that we support are pretty much everything you would ordinarily think of as being required to solve most problems. Now, I'm not getting into the image analytics. We have some support for that. I'll cover that a little bit later on. But if you're doing, classification, trying to, and 90% of what people, maybe 80% of what most people do is really in this realm of classification. They're usually oftentimes even down to just using logistic regression because it's well understood and accepted by banks and things like that. But if you're trying to do regression, like predicting the value of a home or, I don't know, the value of a stock price or a bunch of different things, that's called regression. We have several different techniques for doing that, several different algorithms for doing clustering, anomaly detection. What I think is some of the more interesting stuff here is that we sit within all the other functionality of the database. So if you wanted to use marital status, and it wasn't just single, married, divorced, it was actually a paragraph or a prenuptial agreement or a bunch of tweets or emails. Well, we'll use Oracle text to tokenize all that unstructured data, bring it on as a vector of terms and coefficients, and we use something called TF-IDF, term frequency inverse document frequency, and we'll mine that data as well. If you want to build a partitioned model, like who are you likely to vote for, this candidate or that candidate, and you want to group it by region or territory and say gender, bang, it's just a natural feature of the database. If you want to include geospatial data, graph data like relationships data, all of that is fair game. The database does all those things, and our algorithms can kind of ingest all that data. So it's pretty exciting times. The way that you would access the data is, if you're on the cloud, I'll show both of these briefly, but if you're on the cloud, you'd be probably using the notebooks, although you could just go straight into the SQL code or something like that. You could set up your own, I guess, notebook or something, but we have Zeppelin notebooks that are called Oracle Machine Learning, and it's really just click, click, click off, or type, 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 but we also have a GUI that's coming along with that called AutoML. And then if you're on-prem, you're going to use SQL Developers, Oracle Data Miner that I showed earlier, or maybe RStudio. Python will be coming here in a mere matter of weeks. I'm going to just say this calendar year to be safe. And then it'll be going to on-prem. R is here on-prem, and it will be going to the cloud. So these guys are both going to go this way. And then in the coming I'm going to say months just to be safe. We do have algorithms that run outside of the database as well. That's called Oracle Machine Learning for big data, for Spark, I guess. And but I think a lot of the data that comes out here is really just data that gets boiled down, like counts, totals, things like that. I think there was kind of a mad rush to do everything outside the database out here in Hadoop, and I think that's kind of calmed down. And I think there's a lot of data that's in the database, like age, income, marital status, and maybe the data off the sensors or the tweets or whatever maybe gets boiled down and joined with that data. So regardless, we have functionality for most of these things. Now, getting onto the data scientist type of thing, I've got a blog series. So if you Google Oracle, if you go to the Oracle Machine Learning, just Google Oracle Machine Learning blog, maybe Berger or Smart, you'll get to this whole series of things. There's links in here, and they go off to show you, like in week 4, we'll focus on assembling the best data, or week 3, assembling the best data, and so on. There is an overview YouTube video that actually sounds a lot like what I'm doing right now, come to think of it. And there are, in each week, there's a fair amount of detail. I stopped at week 5 and 6. I'm still in the middle of writing those things, but they're coming. But you can also read a book, and you can also, watch some YouTubes, take some Coursera courses. I think what I want you to do is think about, I'll show you sort of a structured way to go through this, but the way I sort of think of this session is, or this journey is, like if you're trying to learn, a new skill, like learn how to ski or learn how to play an instrument, you don't do it all at once. You take it sort of in pieces. You learn how to play a certain chord, or you learn how to stop, and then you learn how to turn, or, different things. And so what I've gotten here is an outline, like focus a week just thinking about the business understanding. How do I approach a problem? Focus another week thinking about the data understanding. I'll cover this in more detail, but that's the concept of it. There is an OML certification that we're working on that is probably going to be out later on this calendar year, is the hope. And you can take a test and you get certified in this. Right now, the materials that you would read or learn from that are the documentation, the blogs, the tutorials. There's a lot of live labs, and you get your information from a number of sources. I'm trying to, show one that I think is probably a logical approach to getting smarter on this stuff. Under the hood, I still see let me check for questions. Just the one from that we already answered, I think. So under the hood, what we're doing is begin DBMS data mining create model. That's all it is. It's SQL syntax. I'm assuming at least some of the people on this call speak SQL. You probably speak it better than I do. I'm no SQL expert, but I can type in enough. I can figure some things out in SQL. I much prefer to just click on something and have it generate the code underneath that I can then edit, and we do that as well. But I can figure this stuff out, and I think you probably can too. And so we're just saying the model name is by insurance, the type of function is classification, the table or view is that, unique identifier, the target field, like what is the business problem we're tackling? It's who's going to buy this insurance policy. Maybe they're going to go on a cruise, maybe they're going to buy insurance for their home, whatever. And then once we've built this model, we can apply the model on the fly, kind of like what I showed you before, or in batch, however we want to do this. If you say, hey, I would like to do a different problem. I'd like to do attribute importance. I want to know what are the key variables that are driving, who buys insurance or not. Is it age? Is it income? Is it the price of the insurance policy? What are the key factors? That's what we're doing here. And we've identified those key variables down here and given their relative rank with respect to each other and the relative rate, the importance level of them. Now, if you say, well, but I'm a data scientist, I don't speak SQL, I speak R. Well, we also wrap and expose those same in-database functions to the language of R. So now you can come with R, speak your R language, type your R commands using familiar R syntax, but under the hood, we're doing all the math inside the database. The data never has to leave the database. So if you want to use R on billions and billions of record on a properly sized Exadata machine, God bless you. That's what we do. That's what we allow you to do. And there's the exact same results I have over here. This are over here, 0.2161 and so on. Now, coming very, very soon, we've been saying this for a while, it is late, it is overdue and coming, but very, very soon, this calendar year, and there's some technical and also some non-technical reasons why this is a little bit of a slippage here. But if you want to speak speak Python. If you want to speak Python, you can do the same functions, the same 30-something algorithms, but you can speak it from a different language. And it's kind of like, I think of this as going to Google and typing something in one language and translate it to another language and send it to your friend in the other country. That's what we're doing here, except when we send all of our messages, they all go back to core SQL. They get implemented as C code inside the database, and they get fully parallelized as native SQL functions inside the database, regardless of what language you're speaking. Now, you can also do call outs to anything else in Python or anything else in R, but you do pay a little bit of price there, right? Because you're moving the data out of the database. The database will control that with what we call embedded Python or embedded R, and it'll ask the Python or R server to do the math, something maybe custom, some ad hoc Python or R thing that we don't have support for inside the database, and off you go, and it does that, but you pay a little bit of a price there. So if that's what you're doing all the time, Oracle Machine Learning is probably not the best solution for you. But if that's what you're doing some of the time, almost as analytical duct tape or maybe for some quick experimentation, then that works pretty well. This is the Oracle Data Miner drag and drop user interface. I showed just a little bit of that before, but just to kind of keep things moving, I have a quick little demo here. I'm just going to press play. I can go over the live thing, but I did a little bit of that before. I thought maybe a little bit, but we just launched SQL Developer. It shows up a whole nother connection pane over here. That's the code I ran before. This is the workflow. You drag and drop nodes from the far right, and you see the table of data. You see the columns. You see the SQL behind the scenes, because what this is doing is running pure SQL. If I want to visualize the data, I put down an Explore node. And when I view the data here, it's calculated the min, max, standard deviation, and it's throwing up little rendering, little thumbnails. When you click on things, you see the whole distribution. The statistics are all calculated there in a table, and all that's inside the database. We're just using the full parallelism of the database. Here we're doing an attribute importance for the target field by insurance, and we're finding what are the key variables, and that's done through a GUI, but underneath the hood, it's running that same code that I showed you before. The results are where? They're in the database. So I could come back and look at those with Apex, OAC, Tableau, God forbid, or Excel, whatever you want. The math and the data and the predictions are all in the database. Here I'm building several different models. I'm doing a generalized linear model. I'm doing ridge regression on or off, picking my solvers if I want to. There's intelligent defaults for all this. You don't have to worry about any of these things. You could literally just drag, take all the defaults and go. Same thing for like, what's the best model? In the auto ML, we'll do even more automation for you, and I'll talk to that in a little bit. But hopefully you're looking at this and saying, okay, here's a decision tree. I get to kind of understand what's going on here. There's the reasons why. If, then I have a certain prediction probability. I think I can drag and drop these little nodes together and solve a problem. I mean, it's hopefully what you're thinking. And there are my predictions. There's even the reasons why we're making the predictions. That's something we call prediction details. So you can run these workflows. You can save them. You can send them to somebody else. You can schedule them. They're pretty straightforward. So if there's still no additional questions. So if you have any questions along the way, just type them in. R, same thing happens with R. I can call up R Studio here, and I'm just going to do it through a real quick little pre-canned video here. I can go over the live stuff, but this is kind of, I'm being lazy. So here I am setting up. Notice these little packages I'm doing. The package is sort of the handshake between the language of R mapping to the language of SQL. So when I say I want to do a statistic ORE stats or ORE data mining or whatever, it is going to push down the R intentions to the equivalent in database SQL functions. When I do that histogram, it's actually scanning the whole database table, not just a small little data frame in R. It's doing the whole honking table inside the database, right? And when I do my statistics, ORE stats, all those statistics, or what I'm going to do on the right there, the statistics or the box plot statistics, all the math for the box plot rendering is done deep inside the database, and we just return the subtotals. When I do something silly like a scatter plot matrix there's no math going on. It's just throwing up a bunch of data. So that's not gonna, we're not gonna be able to help there. But if you're doing math under the hood, that's what we do. We also have these notebooks. The notebooks come on the Autonomous database, and they are a collaborative user interface for data scientists and analysts. They're packaged with the database. They're easy to access and share, and you can do all the cool things I'm showing here. They're like a little bit like SQL Developer, I'm typing in commands and stuff, but they also have the ability to put little graphs up there. I can schedule these things, I can lay them out, I can insert pictures. And the nice thing about these notebooks is that I can kind of tell a story, and I can say, here's exactly what I'm doing, here's my logic, here's what I'm gonna do next. And it sort of documents and communicates everything that you're doing in a groupware fashion. You can schedule these things, you can do whatever you want. Now, coming in the relatively near future are a number of new things I'm just going to touch upon, because I think it just keeps on getting one, more complicated, but also a little bit easier because there's more and more features and functions. One is the Oracle Machine Learning for Python. And after this little product stuff, then I'll go into how to make this journey, okay? For example, if you speak Python, it's pretty easy because now we're going to speak Python. So you'll go to the notebooks, and here I can start typing in Python commands, and now my native tongue of Python I can use in these notebooks. We also operate the Python integration the same way we do it with the R. So there's this transparency layer. We leverage proxy objects so the database remains in the database. Data remains in the database. We overload the native functions of Python, or also R when we do it with R, and we map it to the equivalent in database SQL functions. So you can use your familiar R or Python syntax to do everything. The hope is most of the time you're going to be wanting to drive the 30-something machine learning algorithms and the 30 or 40 or whatever statistical functions. And the embedded you can do if and when you need to do that. We'll do that better, I think, than anybody else in the industry. But if you're always using open source Python, well, Oracle has another product called OCI Data Science that puts that sort of provisions open source Python on servers. You can even get NVIDIA boxes and do GPU analysis, but it's all sort of open source stuff that we allow you to provision and put a Jupyter notebook in front of it. Here, we're talking about something completely different. This is all Oracle intellectual property inside the database, and that sort of changes everything. Also in this Oracle Machine Learning Python is where you first, which is coming out, is part of 20, I guess we're calling it 21C, I think these days, or on the autonomous database is also where you start to see the AutoML functions. And the AutoML, well, this is still the Python. So the Python here, if I want to do, say, a decision tree, I'm just using slightly different syntax. Okay, but under the hood, it's calling the same decision tree algorithm, and I get a little bit more ability to do some graphics. I can be multilingual, I guess the way I think of it. Under the hood, I guess I have the AutoML somewhere else. Right? Should be an AutoML slide in here somewhere. Where did I put? Oh, there it is, right there. Here's what I wanted to do is put that guy right there. Actually, I wanted to put that for future purposes. I wanted to put him right. No, I'll put him right there. So right after we show what the notebooks are, we want to talk about AutoML. Now, what AutoML does is it does a lot of, it takes all the atomic levels of the machine learning steps that we're going to do, like which algorithms should I use, or set of algorithms, what we call features, like what input variables should I include in the model, and how do I tune the models? How deep should I grow the tree? Should I do a linear or Gaussian model? There's all these algorithm settings. Well, you might have to do this sort of an exhaustive sort of search and trial and error and do stuff. We're going to do a lot of automation for you already. We've always done that, but here we do even more. So we're going to automatically select or narrow down the set of candidate algorithms that are going to be applicable. We're going to automatically winnow out certain variables that we say they're just noisy, they're not very much information containing. So we'll think we'll have fewer models to give you a better, cleaner kind of model, and then we're going to automatically tune the hyperparameters, the settings of the algorithms, if you will. And so this enables non-expert users to leverage machine learning. That's what I like about it. It also is a tool for power users to just say go, and then afterwards maybe I can kind of get more work done faster, or take a look at what the algorithms did, whatever. But it's just automation's good, right? And so that's coming. There are also these new algorithms, gradient boosted trees. XGBoost is what we call. It's won many Kaggle competitions, or been used to win many Kaggle competitions. There's also this process monitoring thing called MSET, multivariate state estimation technique, for monitoring processes. Like the classical one that they've used for over the years has been monitoring nuclear power plants to make sure everything's kind of going along smoothly. There's no real problems with my nuclear power plant, so that's what that does. We've got some faster solvers for the neural networks and a few other things. The big one, I think, is coming, and then we go into how to get from here to there. The big one that's coming is the AutoML user interface. And so that takes the AutoML on the server side that I just talked about, and it puts a new graphical user interface in front of it up on the cloud. So this is part of autonomous. When you get to the cloud, we always say skate to where the puck is going to be. So we're trying to, more and more people are going to the cloud. And when they get there, they'll have this notebook approach, but now they'll have something that's a little bit easier. You'll come up here and you'll say, I want to do AutoML. It'll say, well, what do you want to create an experiment? I want to target the customers. select a data source. I'll say supplementary demographics that ships with the product. It's part of the SH schema. I'm trying to find these hyper responders for these affinity cards. So I give a 5% discount and they spend 6% or more because they're so excited, or they buy things for their friends and family, or they pick up the milk at the store, and clothing, whatever. They buy everything now. Once I set it all up, I can get a certain amount of data profiling. I can get the experiments all ready to go. I just press start. Afterwards, it's going to do a few different things. It's going to tell me what are the key factors that are driving something. It's going to shotgun all these different models and give me the overall accuracy of these models. Over time, it can kind of monitor these models. Over time, it can tell me which model is the best one. And the coolest thing, I think, not a cool thing, is I can also create notebooks. So I can use AutoML. I can just kind of press 4 or 5 clicks, I'm done. And then I can, as a citizen data scientist, hand it over to some other data scientist that can open up the notebook and tweak the code and do whatever they want. So it's a nice way for teams of data scientists to collaborate. And so hopefully you're saying, well, this is getting easier and easier. And that's what our attention is. You can also deploy these models. You can deploy them as just as a, build the model, score the model, but you can also deploy them as a REST API. So if you want to score these things outside the database, you can do that. Call them from a REST API call. We also have something called Oracle Machine Learning Services that allows you to even deploy the models beyond the database. So if I want to have some sort of services that's running and scoring these models, I can take the Oracle in database models and deploy them beyond the database. I have revision control of the models, all those kind of things. I can have more and more monitoring capabilities there, and I also support open source standards like the Open Neural Network Exchange for models. So I can take a predictive model trying to tag pictures of dogs, is what kind of dog is it, something like that. We also have our own text models that we do. So you can export the native models, and we also have some cognitive text and cognitive image models that you can host and deploy out there too. So all of this together, is pretty cool. But wait, there's more. Everything that I've done is available in something like Apex. So I think I have this working over here now. At least I tried to. If it didn't time out on me, here's an Apex application. Might have timed out on me, in which case I might just go back to the PowerPoints. But here I have one error occur. Ajax call. Well, maybe I just let that thing sit there for too long. Let's see if I can do this guy again. I don't know exactly what's happening here. This should work just fine here, but there's usually a graph right here. So I'm gonna go, I don't know what I did there. I upgraded some stuff. I don't know. Maybe you can text me and tell me what I'm doing wrong there. That worked previously. But here's what it's supposed to be doing. I'm supposed to get these graphs, and as I click on these different guys here, it'll update the prediction probability that counts. I can use all the faceted search capabilities of Oracle Application Express to get these results. So now, as a data scientist, I'm really contributing to the reporting with more intelligent analytical dashboards and analytical reportings and maybe mobile devices. I'm really taking these algorithms and their insights and their predictions way beyond the data scientist now. Here are the key factors. That's just that table I showed you before, right? And here's a bunch of other different graphics. And I can do clever things like this. Now, if I have a prediction probability over here for which employees are likely to leave or stay, and I have years by company, I can go into Apex and I can, light up these guys and, select them, and it'll tell me who these people are. I can create a subset. I can do a lot of really cool things with this. So I really like the way that Oracle's moving the algorithms to the database. Just opens up all the rest of what the database does so well, so easily. I can do even more if I have Oracle Application Express, Oracle Analytics Cloud as of 5.7 and going forward. I can take all of my results, whether it's a notebook or a SQL function or an R function or whatever, and I can go over to the Oracle Analytics Cloud. And in the new release, they have the ability to register models. So now I register a model that I've already built in the database. I can go over here, I find the models like these employee attrition models. I can see the information about the models. It's a random forest and so on. I can register that. I can apply that in some sort of flow, apply the model. There's my whole flow. And now I can run in the database and get all of my predictions from OAC. I could, look at these with a bunch of different things, but OAC is a pretty good product. And I have all these filtering, and I can say, well, just show me all the people that have a certain range, a certain probability, a certain department or whatever. I can do really cool graphics. And this is something I just published. If you go to that blog I mentioned before, you'll see this one. I just posted this, did this with some other smart people, Devani Sheth and Sadesh Eugenie. And we took some Kaggle wine data and we did all the modeling inside OML for which is a good bottle of wine and a bad bottle of wine. And we're trying to predict good bottles of wine. We use the text mining. So these are the words associated with good bottles of wine. And I don't make it limited to just the data scientist kind of consumption. I try to surface and expose all this to others. So that's really the contribution, the value add that I think we bring by moving the algorithms to the data. It makes it easier. And the last cheesy thing, I added this recently because I liked it. And I like Marvel comics and those kind of things. But it seems like, right now, if you take all of what we're talking about, it's this sort of infinity gauntlet. It's the most powerful weapon for tackling data-driven problems. You have all the data in the database. We add to it, we have always the security, the scalability, all that, but now we add in the machine learning. There's even this OCI data science that's sort of open source extensions to things if you want to do that. You have the whole Oracle ecosystem, including Oracle Analytics Cloud, and you can do whatever you want, right? Fraud, recommendation engines, clustering, combinations of those things. And so that brings us to the second half of the presentation. Now I'm going to see if there's any, just still, Ashish there is waiting for me to get to this part. So Ashish, here comes. And if anybody else has any questions, just type them in here, or I don't know if you can speak up on the phone or whatever like that, but shout it out if you have anything. I put this part together sort of because it's just something I kept on observing. I just everywhere I go, I just see this. I'd see a lot of data scientists who said, hey, I speak Python, I speak, TensorFlow, scikit-learn, R, whatever. I don't even think of Oracle as a player in this business. What do you guys have? And they look at it and they go, that is kind of interesting, but I'm still an open source Python or R guy. That's where I cut my teeth. That's what I know, and that's where I feel most comfortable with. Meanwhile, there's all these Oracle data professionals that are working back in the back engine room, doing all the work and generating the data and serving it up and doing these derived fields and all this work to support the data scientists and trying to operationalize models and all the stuff that they do. And I've coached up a lot of these guys right now. They're now public references, and I find it's like 10 or 20 to 1 more of these data engineers, data professionals, whatever, people that can spell SQL that pick up these machine learning skills and become data scientists. I see way more of them than people who are, quote, a data scientist that now learn about the database. There's just so much functionality in the database. Privileges, something that data scientists don't even think about, right? Encryption, they don't think about these kind of things. Backup, versioning, all these kind of things the database does so well. And when you take all of those database functions and you add to it algorithms, it's a much easier, shorter path to a solution than coming from the other way at it. So what I have is an approach, as I said, to kind of evolve yourself and pick up these skills if you don't already have the machine learning skills. And the main gist of this is that it's not so hard because you're probably already doing much of the work already. In any machine learning problem, 80% of the work is data extraction, data wrangling, deriving new variables, and this is cleaning the data, all that kind of stuff. We do a lot of that stuff automatically for you, and I'll cover what this is in more detail in a minute, but you're probably doing a lot of the grunt work already. Then there's this little magical part where some data scientist comes in with fairy dust and does some crazy algorithm you never heard of before. Most of the time, there was a Gartner study that just came out last week that says most data science projects or machine learning projects are done with a very small subset of algorithms. They're like the logistic regression, decision trees, clustering. They sort of use the same ones over and over again. You'll always read in the press about some new exotic thing, but most of the time they're using a small set of algorithms, and that's what we have in spades inside the database. So there's this magic part that happens, but it can happen inside the database and you can do it. And then this part about importing the predictions and insights and moving them back and forth, that all gets obviated because, or eliminated because we're doing it inside the database. We're not schlepping data back and forth. So you're already doing a lot of this work, and when you realize how little the additional work is, you kind of say, I think I could do that. And that's what my encouragement to you is that I think you can do. The way that I point this out is using this age-old CRISP DM methodology. Now, I was a little bit involved with the definition of this with some others in the industry way back in the late 90s, I guess it was. And I thought it was so simple, it was stupid. But it's held up over all the years because it is so simple. And it really just says there's 6 major steps. You have to have a well-defined business statement, and this is where most people screw up the most. And if you read my blog, you'll see a bunch of examples of that. Then there's the data understanding, like, well, don't start with the data. Now with this data, what can I solve? Start with the business problem. What are you trying to answer? Like if you're trying to figure out which employees are likely to leave, start with that and then figure out, well, what are the variables I would need to maybe predict that? If you're trying to figure out who's going to default on a loan, think about those variables. You're going to say, who's going to buy a spaceship? Well, maybe you have to think of, do I have data that ever shows who did buy a spaceship? Maybe some problems cannot be solved so easily, right? Or there's only one person. It's not a machine learning product that does that. So there's this whole sequence of steps that you do that we'll go into. They can be very tedious. They can get kind of overwhelming because they're real. You have to do these kind of things. You have to normalize the data. You have to do stratified sampling. You have to deal with unstructured data. You have to do with univariate and bivariate statistics. You have to embed the application, the model in an application. There's a lot of, you have to figure out what's the best model. Well, the ones I've dimmed, we have reasonable defaults for, or automation. You can manually do whatever you want, but you can also just accept all the defaults. So what's left in the bold black are the meta kind of things you need to think about. And I contend that most of that is common sense. If you're in a shoe company, you're trying to figure out, well, who buys a lot of shoes? You know that. You know what the data is you should bring together. You may want to know some engineered features like what's the ratio of dress shoes to sneakers or something like that. Or, you know, what's the, how many shoes did they buy last year? You know, all the variables that you think you know about the business. Are they buying leather or are they buying cloth shoes? So if you know your business, you kind of know how to ask the smart questions and how to assemble the right data and think about it. And I'll go into that in more detail. So there's a lot less work to be done here than you might think. If you're using the Oracle Data Miner drag and drop GUI, well, we designed this in such a way that most of those steps are in fact nodes. So if your business problem, you have to kind of decide what it is. That's what the whole workflow is all about. But then when you understand the data, that's an explore node. Maybe you understand the data with some attribute importance. That also fits in there pretty well. The modeling is the modeling node. Now that actually does the splitting of the data into train and test, usually a 60-40, 70-30 kind of split. All that happens by default over here. If I want to do data preparation, well, we actually do a lot of that for you automatically, so you don't have to worry about it. But if you do want to do a derived variable, like I want to recode age into low, medium, and high for whatever reasons, or I want to have a great amount of granularity around teenager years, or I want to take lifetime value spend with the customer, and I want to bin that into low, medium, high, very high, well, there's a certain amount of domain kind of transformations you may want to do. For the transformations that are required by the algorithms, you can just take the defaults. Our automatic data preparation will do all that stuff for you. So there's a very easy to use approach that we provide for you as part of SQL Developer. If you're going to the cloud, well, we have a bunch of example templates that I'll show in a minute, but they are just notebooks that have the code that, you know, when I click on building a model or I click on apply, well, that's just actually a paragraph in any one of these notebooks that does those things. And so there are good examples of all that. So here's the evolutionary journey. Here's sort of my, words of wisdom, if you will, on how to approach these things. And again, it's like learning how to ski, learning a sport like tennis, how to swing, how to first hold the racket, then how to swing the racket, maybe a forehand, maybe a backhand. Later on, we're going to learn the serve. We're going to learn the rules of the game. So if you take all these in sort of bite-sizable chunks, it's a lot more approachable. So, so week one, it's all about business understanding. Week two, data understanding, and so on. So here we are in week one, and we're going to go through like 6 weeks, and then at the end of this, you'll all be data scientists, and you can go off and have the make a lot of money, have the sexiest job on the planet, that kind of stuff. So week one is start with a well-defined business problem statement. And the ones I have here are ones that get brought to my attention all the time. These are terrible, terrible, terrible business understanding statements. They're way too loosely defined. What is your definition of a best customer? I have no idea. Predict employees that voluntarily churn. Okay, I could predict everybody that's going to churn like 1 minute before they turn their resignation letter. You probably want to have a 3-month advance warning on that. How can I combat fraud? Well, what's your definition of fraud? I don't know. And the worst one is this last one. Hey, I've got all this data. Could you mine it? I want to see if your tool works. So take all this data and mine it. See if I can find some useful insights. Just walk away from that one. It's a waste of time. What you need to do is you need to think about a very well-defined business problem statement. And I always go back to Albert. Albert says, if I had an hour to solve a problem, I'd spend the first 55 minutes thinking about the problem statement and the last 5 minutes thinking about solutions. And the example that I use in my blog, I think, and I've heard, I guess, Albert mention or whatever, or maybe it wasn't there in the room when he said it, but it was maybe written in a book or something. But I think the question goes, if he was asked to save the planet, the question is, well, okay, what do you mean by that? What do you mean by the planet? Is save all the men, women, and children, or just the women and children? What about the animals? What about the trees? How long do I have to save them? If I have to save them for eternity, then I just put them all in formaldehyde, right? And come back eternity later, and there they are. If I need to save them for 5 minutes while an asteroid swoops by and maybe hits the planet, maybe misses the planet, then I could just beam them all up into space for 5 minutes and beam them right back down again, and that would be my solution. So you can see that you really have to think of a well-defined business problem statement, and that helps you get on the right track. I can tell so many stories about people that have really sort of, they said, well, I want to do some clustering. I really want to do some clustering. This is a true story with Procter & Gamble. It's a public story. I did it at Oracle World with Procter & Gamble. And they wanted to do clustering. And we got done doing the clustering of, I think it was Walmart store data. And the guy goes, oh. And I go, what happened? What do you mean? And he says, well, I thought we were going to find, I don't get it. I don't see anything of really interesting. I just find these clusters. What do I get out of this? And I said, what did you think you were going to find? He said, I thought I was going to find the characteristics of well-performing Walmart stores selling a lot of P&G product, toothpaste, all that kind of mouthwash, all that kind of stuff, detergents, and how much advertising, how much shelf space, how many people worked, how many hours, all that kind of stuff. And I could compare that to ones that were not performing so well. I go, well, that's a classification problem. Has nothing to do with unsupervised learning. And so we just changed the workflow around a little bit, ran it again, and now he's happy. So you really have to think about your problem statement, and you have to stay out of the sand trap. I'm not much of a golfer, but I know they have these things called sand traps. And if your ball lands in the sand trap, you waste a lot of time swinging at the ball. And it's because you have a poorly defined problem statement. So you're going to do rework, you're going to come back, your boss is going to get unhappy, you're going to be unhappy, because predicting, who are my best customers, which customers are likely to buy what, when, these are just way too loosely defined statements. And you're going to waste a lot of time. So here's an example of a poorly defined business statement on the left that gets cleaned up a lot more in the middle, and then that naturally flows to a machine learning function. So the very first one, predict employees that are likely to leave. Sounds good, but really, do you have a field in the database that said these are the employees that left? You probably just have they were active up until this date. Well, do you have a reason or a cause code why they left? Because if they died, God forbid, you don't want to predict people that died. And if you fired them, you don't want to predict people that you're going to fire. If they wanted a maternity or paternity leave, you don't want to predict that. So you want to think, I want to say all the people that voluntarily left that I did not want to leave, I want to flag them with a 1. Everybody else, I'll flag them with a 0. So now I've narrowed the problem down to a nice, simple classification problem. But it's more complicated than that, because, as I said before, if they're going to leave, you want to know how many days, weeks, months in advance that they're going to leave. Maybe you want a 3-month early warning system, which means now you have to look at the problem and say, okay, those people that did leave, they gave their notice, and I go, wow, why are you leaving? I have to look at, what did they look like 3 months before they left? Did they just recently get married? Did they just recently get a bonus or not get a bonus? Or, what happened? Are they traveling too much then or not enough? So really think about the problem carefully, and then that drives what algorithms would work best. In this one here about how can I make more money, everyone's asking that question. This was actually with Dunkin' Brands. A guy I used to work with left and became a leadership lead in the BI, I think manager, director of data warehouse and business analytics, something like that. And he was trying to make more money, but he was smart enough to know what I'm really trying to do is make a lot of profit selling cold, coffee that I've made as iced coffee. Also drinks, any kind of drink, they make a lot more profit on those things. So if they can find out what things go with iced coffee, like maybe sandwiches in the afternoon, they extend their day. Another restaurant I know was also trying to sell a takeout kind of restaurant, sell a lot of like big gulp kind of drinks, lots of, sugary water. They make a lot of profit off that. Well, if they know what goes with that, and some of these things, they uncover the market basket analysis association rules, and you kind of go, oh yeah, that makes so much sense. but not until the algorithm sort of found that pattern, served it up to you, and you validate it, and you say, yeah, that's great. Thanks for showing me that. Salty things like, a ham sandwich are on sale all the time because then you buy a drink with it. A bag of chips for free because then you buy a drink with it. All those kind of things. So think about the problem statement as explicitly as you can, and then that will map into some sort of machine learning function. That is the essence of week one. If you read the blog or you read a book, there's a good book by Michael Berry and Gordon Linoff, two guys I used to work with a long time ago. Michael Berry, B-E-R-R-Y, and Gordon Linoff, L-I-N-O-F-F, and I think it's called Mastering Data Mining. I've got it on one of my shelves over here somewhere. They've written 2 or 3 different books, and it's a good book. There's a lot of other good books, but it gives countless examples of how to think about and how to approach the problem, just like Albert in those earlier slides. So when you do the business understanding, if you use the notebooks, and in this case, we're targeting best customers, but it's not only best customers who have good credit ratings, it's actually their best customers because they have good ratings, because I could just get a FICO score and say, well, this guy has a 785 FICO score, that's great. Well, they also make all their payments. If they're buying a flat screen TV or a large appliance or maybe a car or something big they're buying, and we want to know that they can buy it, but then also they can complete all their payments. And the business problem here is they're getting returns because the people can't keep up. Maybe the economy's not so good, I don't know what, but people are returning things, and we want to say all those people that actually finish out all their payments for something that's a big ticket item, I want to flag those guys as ones. And if we look at the data, what we're calling good customers by that definition, so we have sort of a business rule to flag them as a 1, then there are, 20-something% good customers, and most of the customers are not so good. Now, I could build a really simple model here that says, always predict the not so good customers, and I'd have like an 80% accurate model. I'd be 100% right on these guys, but I'd be always wrong over here. So I have to think about the problem, set it up, and make sure I do stratified sampling, make sure I do a lot of other clever things. But that's week 1, trying to set up the problem. I'm looking at questions. There's still no additional questions, so I'm going to keep on going here. Week 2 is, does the data make sense? Review the data. Are all the ages what you would expect the ages to be? Are all the incomes what you'd expect them to be? Are all the loan amounts reasonable? Does the data make sense? I had one set of data with an application we built, a human capital management application with Oracle HCM. It's called Workforce Predictions. We actually got the data from our, it was the India Development Center is what we were given by Safra Katz. And I got my hands on the data, and I looked at it and I said, holy mackerel, the average age, when I put it up in a histogram, the average age of all the employees in the India Development Center was 13 years old. And I kind of asked some questions, and what's going on here? This is crazy. And what we realized was it was crap. It was bad data, because if they were hired into the company, we knew their age, we hired them in. If they came in through a transfer or an acquisition, we just knew the transfer, the acquisition date. So there are a lot of people in the database with 1, 2, or 3 years of experience. Hence, the whole bimodal distribution gave for an average 13. Now, we still built 95% accurate models in the first decile, because there were all these other, you couldn't be a 13-year-old person with 20 years of Java experience. The other variables, or their age, their marital status, the other variables sort of overpowered the bad data and showed the real relationships, and we were able to build very smart, very good models. But it would have been a little bit easier if we just had better data too, right? So you want to look at the data. You might want to look at it in various different graphical ways, simple exploratory graphs to understand the data, and in much part to validate the data, make sure it makes sense. That's what we're doing here, looking at the input data. We're also starting to think about what are the variables I would really want to bring into this model, because this data may lead me to think about other variables that might be a little bit better than the ones I have. I might have age, but what I might really want to know is how many years have they lived in the same house? You might think that's a little bit better predictive variable for where you're going to go to college, or all sorts of different things. So you're looking at the data. If you're using the drag and drop GUI, you'll get a user interface a lot like this to do that. If you're using the notebooks, you get something a little bit more like that. We're in the middle of week 2. We're ready to go to week 3, data preparation. So now in week 3, I'm going to say I'm a lazy data scientist, but I'm going to say it in a nice way. I'm an efficient data scientist, because I'm going to say, I want age. Hey, Oracle Data Professional has the keys to all the data. Do you have I'm trying to predict which employees are likely to leave or stay, or who's going to default on a loan, or who's going to buy solar panels, or typical problems like that. Oftentimes, I need the person's age. Do you have that? And they'll say, no, but I've got their date of birth. And I go, could you compute that, or how do I do that? And they say, I could do that for you. So I'm going to say, okay, thanks, I'll take that. Same thing on the address. I don't really care where they live. I don't care if they live at 12 Main Street. I care how far is that distance from here to there. And I can use Oracle Spatial in the database to do that. I can even use Oracle Spatial to calculate commute time. If I'm trying to predict which people are likely to be good candidates to take the job at the downtown hospitals where the traffic patterns are terrible and might take you 2 hours to get into downtown. I want to know your address, but I want to know what the commute time is for the third shift or the second shift or whatever that job opportunity is, right? So that's a better variable. And I've got a lot of data preparation. That's what I'm saying. A lot of you on the phone right now on the Zoom may already be doing that work, right? Then I have things like the number of dropped calls. So if I'm trying to predict churn, I might say, well, if I called you and you call me back and then I call you back all in a short span of time, that is the equivalent of a dropped call, right? So I might ask, can you count the number of dropped calls? Now there's a feature in the database called SQL patterns that was designed, this is a true story, for Turkcell, because that's where they were doing a bunch of SQL code to do that. And so Oracle developers put that in as a special function. I would want to use that as an input to a predictive model. So you can see how it goes on. Like notice salary, I want to get like your percent raise or your percent bonus compared to your peers, because if you get a 6% bonus or 6% raise, you might say, well, that's great, but if my office mate got a 16% raise, then now I'm unhappy again, right? So that kind of information gets around. You want to think about those things. Those are more cleverly derived variables. Also in week 3, we're trying to do a certain amount of data preparation. We're trying to look for the right variables. We're also trying to do engineered features, which are the derived variables like percent raise compared to the peers, things like that. We're also doing things like dealing with missing values, outliers, too many constants, too many distinct values. And the Oracle Data Miner column filter node that I showed earlier in the workflow does a lot of this for you. It will calculate which variables don't have any minimum importance, which variables have too many constants and things like that. And that's really handy. Something we do in each of the model builds is called a certain amount of data preparation, automatic data preparation, ADP. So in each algorithm itself, so you can do it explicitly outside or in the algorithms. There are also settings in the algorithm build that handles missing values, outliers, binning, too many distincts, too many constants. And you can correlated data would be something found by the ridge regression or so. You want to watch out for things like that. So there are things that you do that you want to kind of keep an eye out for. We're going to give you intelligent defaults for most of that, but there are automated features and functions for helping you with these things. And so that's why I keep on saying, once you know the concepts, it's not so hard. You can accept the defaults and keep on going. Like for missing values, this is a common one. Most competitive products would say, oh, I've got a variable like age is missing or gender is missing. I have to take and throw away that whole row because it'll corrupt the rest of the model if I have missing values. We say, why would you do that? Why don't we just replace the missing value with the mean or the mode and keep going? So we'll do intelligent things like you can override, do whatever you want, remove the field or change it as a different value, but we're going to do that kind of stuff in a more automated way to try and get you a better answer more quickly. And you can always override. We're up to week 4. We're doing the modeling. Now I show this as 2 or 3 different kinds of modeling things you might do. The first one, it says, let me just find out what are the key variables that are driving this particular business question. Here we're trying to find what are the attributes, the variables that most influence the target field. So here the target field are the good customers who complete all their payments. Well, I want to know, it's clipping right here, but what are the key variables? Is it age, income, number of previous purchases they made completions on, marital status, are they a silver, bronze, platinum loyalty card user? Do they buy their tires in that store too? I mean, what are the factors that most drive that? And that would be just this begin DBMS data mining, create model right here, create model. Model type is an attribute importance. It's the same thing as I showed before for the code. So that's all it is, just building a model. And my experience with most Oracle data professionals who speak a certain amount of SQLs, they look at that and they go, yeah, okay, I get it, I can do that. And if you use the GUI, it's even easier. And if you use the AutoML user interface, it gets even easier. So we're trying to communicate this gets easy. I think you can pick the stuff up. In week 4, a lot of people I asked, how do you know how accurate the model is? Do you know how we do that? And they'll kind of give me a blank stare and go, I don't know. What do you do? Well, it's straightforward. Once we tell you, it's like Penn and Teller. They tell you how they do the magic tricks. This is a very straightforward one. If you don't know this already, it's straightforward. We don't mine on necessarily all the data. If you have 10 million or 10 billion records, we don't need 10 billion records to find a pattern. We can do it, on maybe 1 million or 10 million records or whatever. But even with that data, we don't mine all of the data. We typically take about a randomly selected sample of the data, and we'll typically have a mix. 60% of that data we'll use to build the model, but then we'll have a holdout sample. We'll take the other 40% and we'll set it aside, and we'll use that because it comes from the same distribution of data. We'll build the model on the first set of data, and then what we do, we'll get the model, the algorithms will build a really good model. We'll then apply the model to the test holdout sample of the data. And based on how well we can predict the values, the known values for the historical data, we sort of predict the past, then we get to evaluate the model. How accurate is this model? If we learn, but then we predict what we already know, we can measure. And so that's how you know how good the model is. Now that little 60-40 random sampling, split holdout sample concept is something that's just core to all machine supervised learning models. But if you don't know it, you don't know it. But now that you know it, you go, oh, okay, that's straightforward. I'm almost a data scientist now, right? I get the core principles of what's going on here. If you're using the Oracle Data Miner drag and drop GUI, you build multiple different, you may just build one model, you may build multiple models. We're going to typically build multiple models for you and let you compare them all. And it's this nice little workflow here. At the end, you're going to get a lot of different model viewers to evaluate the models. And we're up to week 5, evaluating the models. So here we've built a number of different models. This is called a cumulative gains chart. There's also a lift chart that's very similar. And what you're doing is just trying to say, out of the blocks here, 20% of the data. So if I have 10 million records, 20% of the data, I'm going to find 65% of the people I'm looking for. So if I'm doing random sampling in order to find what I'm looking for, people who default on a loan, or people who buy a Buick or buy a boat, or high value customers, or people who buy over $1,000 worth of coffee or whatever, to find them without any knowledge. If 15% of the people do that, then if I go into 20% of the population, I'm going to get 20% of the 15%, just using the naive guess. If I go in with a predictive model, I'm going to get what? Instead of 20 here, I'm going to get almost, I'm going to say 3 times that, 60%. It's a lift of 3, and it's at this point, after 40%, I've gotten almost 95%. So it's a way more efficient way of finding the people. And now all these models, I'd have to say the red one here is the best. I think it's the random forest, but they're all better than the naive guess. They're probably all better than what you're doing. Even if you use the worst one here, you're still going to be doing fine. In the AutoML, we'll do all this automatically for you, and we'll pick one. In what we do today, you'd run one or multiple ones. You'd have to use some judgment to figure out which is the best one. And there are these gains charts, lift charts, accuracy. There's a bunch of different things there, but it's some of it's a matter of judgment. But you pick one, okay? You pick one, and any one you pick is going to be pretty good, and I wouldn't sweat it that much. Now we're up to week 6. We're deployment already, right? We already built our models. We evaluated the models. We picked one, the red one, the random forest. We could have picked the yellow one, the support vector machine. We could have applied all these models and used sort of a panel of experts. Like 3 out of 5 models think this is a fraudulent claim. Pull over. We want to investigate you, Once we have the model is this N1 class model. Is the name of the model here. I can just use that in a SQL query, apply the models to predict the best customers. There's my list of customers with my probability. Straightforward. It's just a script, right? The data, the models, it's all in the database. Just run it as another script. You'll build them out. It's like a macro. People think of this as a PL SQL procedure. It's way more tightly integrated. It is actually just a SQL function at that point. So I build a model, deploy a model, move the model and the scripts up to a different database, productionize it. And here I've productionized it with a whole script here. Drop the previous model, build the model, select the best customers, put a timer on this thing, have an event trigger goes every time a new record is submitted, score it once a day, once a week, whatever. If you have something like a Fidelity or one of your money funds, every night they upload all the data. You could upload it all, run all the scripts, and predict everything as well, too, right? So you're now thinking of all of what you're doing with Oracle data today as a data professional, but now hopefully you're thinking about, hey, I could add in all these predictions and insights from this machine learning because it's not as hard as maybe people purport it to be. We're essentially done. There are a number of resources you can go look at. The Changing Role of the DBA is a blog series. It's 3/4 written. I still have to write a couple of the last chapters, but you can also, look at plenty of other, look at the notebooks, look at the YouTubes, look at other different hands-on labs that we have over here. So I'm just trying to codify that a little bit better. But there are a lot of YouTubes, resources, buy a book. My encouragement to you is if you are already an Oracle data professional, becoming an Oracle data scientist is not so complicated. It's very, very, just climbing up on that ladder or one more rung and you're there. I'm the co-founder of this group here, the Analytics and Data Oracle User Community. So kind of like what you guys do. This is a worldwide event, although a lot of us are based out of the United States and Europe, I guess. We're always looking very much welcoming and accepting other people that want to volunteer and help in the leadership of this. We just had our TechCast days. These are all the recording things are public. So we had Certergy, we had Hartford Healthcare, we had Kasha Bank. I gave a talk, a bunch of Oracle aces, and we record them all. We put them on our YouTube channel. They're all there on the website. So just go to ANDOUC, Analytics and Data Oracle User Community.org. It's a separate company. You can see all the TechCast. Hopefully, we'll get you guys on stage and share with others what you're doing using the product. That's what it's all about, right? Get novel and interesting use cases given by experts, people that have done it, and share it with others. So it's a community of sharing, and I encourage you to join, come and watch all the things that are on demand. We must have 30, 40, or 50 YouTubes that are already recorded out there. You can just check them all out. They're on Graph, they're on Spatial, they're on Oracle Analytics Cloud. We have, a bunch of really talented people out there showing their stuff. And at the end of all this, congratulations, if you stayed up. It's getting a little later here in the Boston area, but wherever you are starting out your day, you've already, followed this for, almost 90 minutes here. And, hopefully you're on your way to becoming an Oracle data scientist. Like I said, we are doing a certification. I'm also working with Oracle University, although that's going a little bit slower than I had hoped. But I think it's kind of a self-study approach, like take it in chunks, think about each of the different problems, do a little bit of homework. Like any new skill, just take it in chunks, learn, practice, think about it. Maybe read the blog, read some books, watch the YouTube videos, and think about how you would apply in your own thing. If you want, reach out to me. I'm happy to kind of coach you up. If you want to have if you have a company, you have a lot of guys at it, or you're a partner, reach out to me. I'm happy to help guide you. I think there's a lot of resources, and I'm happy to help you along that journey. I think it's a very what I'm excited about is I think now that we're free and now that we've made it so much more easier to use, have fun. I can't imagine what the next 5 years are going to be, or 10 years, even in 10 years, what people who are, using their data in the database and have machine learning, what they can do. You can only imagine, web-based applications you download and you load up all your SAP expense reports, get a predictive score for the likelihood of there being a fraudulent claim in there, or your taxes or whatever. The person who writes these apps maybe charges a nickel a score, who knows what. Your database maybe has all the past values, but all the predictions and the probabilities and the reasons why, that what we call prediction details. You can just kind of imagine that movie Minority Report and think, hey, that's actually quite achievable. So I hope you have some fun with all this stuff. Thank you for your time, sticking through this whole thing. If you have any questions, reach out to me, and I'll open it up. I don't know if there's any questions. I only see in the Q&A, the one from Ashish. I don't know if there's any more. Any questions out there, Suresh or anybody?
Yeah, no, I have not seen any questions, and the session was really great, Charlie. And this is very insightful. It looks so good. And I don't see any questions. If anyone has any questions, please post. Otherwise, we can wind up the session.
All right, guys. Thank you.
All right. Thank you so much, Charlie. Thank you for your time. Thank you. Bye-bye.
Thank you, guys. Take care.
Thank
Bye.
you.